We'll talk about using VR, AI, and 3D printing to make spacecraft structures. All right, Ryan, you can take it away.
Okay, I'm also going to make a valiant effort at a live demo. Can folks hear me and see my screen?
Yes, we can hear you, and we see the presentation up.
Okay, so I'm going to start out with the presentation, just for some intro stuff, and then hop into VR so I don't have to go back and forth. I'm just in the Steam desktop here. So I'm going to talk about VR, AI, and 3D printing, three exciting new technologies, how I'm using those to make spacecraft structures. And this is going to be maybe a bit of a different talk from some of them. This is more of an end user workflow. I'm a mechanical engineer, a research engineer is my title, and I'm just going to show how I'm using VR in my sort of day-to-day work. So I'm in the Instrument Systems Technology Division here at Goddard, and research is what I'm doing when I don't know what I'm doing. Okay, so for context, my background, I'm a mechanical engineer, mechanical systems person. I've been doing design and analysis for the last 20 years. I've worked on all kinds of familiar stuff, Hubble, ISS, pistol grip tool for folks that know crew aids. And I've never really been satisfied with the cost and quality of computer-aided design and engineering tools. And it's sort of my theory that there's a direct relationship between the programming skills in a profession and the quality and cost of the tool. So, of course, programmers can all program, so you get Python, which is awesome and cheap. And then very few mechanical engineers could program, at least when I got out of school, so our tools tend to cost $10,000 a year and be of poor quality. And I'm hoping to see that slowly shift over time. And I've been fascinated by virtual worlds since the Wolfenstein era, Wolfenstein 3D way back when. And I've been a VR enthusiast since really before even the Oculus DK1 came out. And here's sort of my how it started, how it's going meme. So like, here's me in the DK1, and I think Shayna, actually, the previous presenter trying this DK1 was her first VR experience. And then on the right, here I am in full body tracked in my VR chat avatar. And that avatar is actually in the credits of a film at Sundance Film Festival. If folks are interested in that, they can ask me more. So I've been trying to apply VR and AI to my subject matter expertise, which is mechanical systems. So I've been trying to infuse VR into my current projects where it makes sense. So I have an IRAD for generative design and digital manufacturing, which is, I call it using AI and robots to build structures. So generative design is AI coming up with designs, doing the analysis and optimization. And digital manufacturing is robots directly fabricating from the 3D data. So can you folks see in the upper right-hand corner, there's this very organic looking part?
Yes.
So it was designed by AI and then subsequently tested. And the interesting thing about it is that it's 3 times stiffer and stronger than a similar design made by a human or solving the same problem. So we can make structures 2 to 4 times lighter and 5 to 10 times less development time and cost. And there probably aren't a lot of mechanical engineers on this call, but if there are program managers and people that care about time and cost of projects, it's a very fascinating technology. And my other work is making ultralight nanometer precise optics for future X-ray astrophysics missions, and this is one such mission. And the goals of this presentation, I want to share what I've learned about using VR for mechanical systems, and maybe you'll tell your mechanical systems friends, and inspire other folks to embrace VR in their actual workflows, and to share my pain points to guide future software development. So my inspiration for the generative design work really comes from science fiction. Through the pandemic, I've been watching a lot of The Expanse, and you see all these huge space stations. But I know how the sausage is made, and it's a little disappointing to see that we're just not going to get there the way that we develop things now. If you take the cost of most of our missions and you divide them by the mass, you end up with something like $250,000 a kilogram. So I think we just need to get a lot lower cost. So this quote is very inspiring to me, that AI is one of the most important things humanity is working on, more profound than electricity or fire. So I've been thinking about how I can apply AI to my domain expertise, and then also VR, which I'll get into later. So generative design, if you haven't heard about it, it's an AI that outputs multiple design options based on some input constraints. So this is the DALL-E AI of Google, An armchair in the shape of an avocado is the input, and then the AI generates all these images. And you can see that some of them are really good, some of them are kind of bad. But the AI even had the idea to use the seed as a pillow. So this is really fascinating to me. And there are a lot of applications, visual art, music, architecture, and I'm talking about structural design. And DALL-E 2.0 was just released yesterday, I saw in my Twitter feed. So given this input, an astronaut playing basketball with cats in space in watercolor style, the AI came up with this painting and a bunch of other ones. So these are not done by humans. And these are just a sort of potpourri of examples of things that I've applied this technology to through my iRad. Okay, so now I'm going to make an attempt to jump into VR and show you how I'm doing this in my actual workflows. Okay, can folks see VR now?
Yes.
Yep.
And I will try not to make people too dizzy by bobbing around. So here's an application I had recently. There's this silicon wafer that was bonded using laser welding, and it's a really interesting application. And I wanted to see how strong is this little wafer. So it's kind of a simple thing, but maybe would take people a little bit of time. So I hopped into Gravity Sketch and I sort of used 3D thinking to think about this design and how I would make a fixture that did this really, really cleverly and quickly. So I did this, rough sketch in Gravity Sketch, and then I went to my 2D CAD tool, or screen-based CAD tool rather, and made this design. So I don't think I would have come up with this clever mechanism that I'm about to show you if I hadn't done it in VR. So you have this little thing which is kind of like a slide, and this piece slides into it, fits in there. And then it leaves a little gap where I can put the sample in. So I can drop the sample right in. And then when I slide this over, there's a little catch on the back that applies the load. And then I put this bolt in, and then I can do this pull test. I can just pull on this and find the strength of that bond. So here is an image of what that test actually looks like. It supported 30 pounds, that little tiny bond. And what's interesting about this to me is that I was able to go from having this problem to doing this test in one day using VR and additive manufacturing or 3D printing. So I think if you were to just, give this to someone who was using traditional tools and ask them, can you find the strength of this? They would probably tell you, come back to me in a week or two. So any questions about that application before I move on?
Doesn't sound like it.
Okay, so here's another application. Yeah, I'm kind of blind to Teams at the moment. Here's another application where I have these X-ray mirrors, and I brought them in from a CAD system, and I need to develop a novel flexure mount for these mirrors. So I bring them into VR, and I can really easily and quickly sketch, complicated things like these little tiny flexures that you're probably seeing on your screen now. I can zoom in and model these really tiny things. I can make myself like the size of an ant, and I can make these kind of extremely detailed structures, and then I can zoom back out and continue working. So what I was able to do with this is come up with a novel arrangement of flexures for these optics. And I realized when I was demoing this to a friend that I know how big things are to me, but since you are looking at on a screen, I had to include the banana for scale. So this is where the generative AI part comes in. So in VR, I kind of like mapped out, for a test bed. Basically, I want a test bed where I can try this out quickly. I mapped out, the areas that I can have material in my design, which are represented by green, are areas where I need to have material. And then represented by red are areas where I can't have material in my design. So this is all I give to the AI, basically where you can have material and where you don't have material. And then this is what it came up with. So you can see that it came up with this sort of beautiful organic design very, very quickly. So in this case, I mostly just used it for speed. So you can see when I line these up, how it basically took my constraints and then designed something from it. And, you know, I used VR to sort of lay out how this was going to be designed. Let's see if I can grab one without the other. There we go. So yeah, this is another case where, you know, what's interesting about this is I was able to come up with this novel arrangement by really thinking, you know, in 3 dimensions, and then was able to, in about, you know, 1 day, come up with this design, print it overnight, come in the next morning, clean up the print, and then test this out the next day. So here you can see what it looks like, this photograph. I'll try not to jiggle around too much. So that is the real hardware. Okay, so a third example is this optical bench. I'm going to change the lighting a little bit here.
So Ryan, for that last one, how many different designs did the system come up with that you had to choose from?
So on the order of a dozen or so. So it depends what you know, what you input. You can input, okay, show me one that's additive manufacturing, show me one that's different material. You can have sort of different generative algorithms that are running. So it's up to the user, but, you know, on the order of, say, you know, for a problem like this, on the order of, you know, a half dozen to a dozen. So there's really a human in the loop
Sure.
required for this. You know, sort of, it's, you know, when you work with most AIs, it's kind of like, you know, collaborating with someone that can be very, you know, very brilliant or very thick. So you really have to you know, tweak your inputs.
Yes.
So for this application, you know, the human design was this, you know, very standard looking, you know, boxy, blocky optical bench. And then I ran it through my generative design and came up with what you see here. So this is 1/6 of the mass of the original design, and it is also stiffer, and it combines 7 parts into 1 part. So, you know, for someone who wants to save weight, it's very, very convincing. So what I brought this into VR for is first to see it's way smaller than I thought it was. So I really get a sense of scale that you can get by seeing this mannequin here. And then I also realized that I did not leave anywhere near enough room to get this lens element in. So I've got to leave some more clearance there. You know, if I look here, I also didn't leave enough clearance. And then, you know, these little flexures are supposed to get adhesive bonded, and they're just too small. You know, that's the design that someone comes up with when they don't realize that this thing is actually tiny. So again, I was able to come in here, do a quick check of this very novel design that people are very, you know, people see this kind of alien looking thing and they're concerned. So I can bring them in here and then show them, oh, well, you can integrate it. And then they can point out issues, and then I can go back in and rerun the generative design with new parameters. And another kind of fun application is, you know, also like, how do you blanket something like this? So I can sort of, you know, think about, you know, how you might put an MLI blanket around this just really super fast. So there you go. Okay, any questions about this one?
So how do you get your constraints over to the AI and have the AI iterate over it? What does that interface look like?
So it's basically, I'm using a program called Autodesk Fusion 360. So I basically, you know, I can take, you know, if I'm in VR, or if I'm just thinking about it, what the constraints are, like I showed with the red and green part over here, and then that is put into a piece of software called Autodesk Fusion 360, and Autodesk Fusion 360 is what generates the model. Okay, so a final application here is something that I heard lots of other folks touch on, is you know, collaborating. So this is a a fairly large titanium piece in terms of structures. It's additively manufactured, and it's actually just got finished printing. But with this part, I went and collaborated with an expert at Penn State, Tim Simpson, that runs their SIMP 3D lab. And we were able to hop into spatial.io together. And this is just a research part, and look at this part together. So being able to bring, an outside expert in to look at this, and he could look at it and think of all the different orientations you could print it in, and look at it and see, okay, so we've got some overhang angles here. We're probably going to need support material, and where these bolts are. Maybe you can grow the material around that bolt a little bit, so we don't need as many supports. And in fact, this was like an earlier design that we decided to simplify for additive into this design. So it really just allows you to quickly hop in, and more so than you can do on a screen, really get an idea. You just see things in VR, as you all know, that you just don't see on a monitor. All right, so now I'm going to pop back into my presentation. Can everybody see my slides again?
Yes.
Okay, so this is just the slides that I talked to already. And just to give a conclusion and a call to action, XR is it's ready for broad infusion into mechanical systems workflows and to other folks' workflows, folks that aren't IT folks. Our USO Nest laptops that we have here at Goddard and other centers are capable of VR with the NVIDIA RTX cards. The headsets are assessed and cleared and pretty easy to get a hold of, though the HTC, I had an issue with Section 508 here at Goddard. And there are a lot of different software options that are available, both things made by internal teams and external teams. And I would just advise folks to, if you're working on some interesting tool, look for the innovative engineers that are going to carry the torch forward for their discipline. And I know there are a few mechanical folks at Goddard that are doing that. And the pain points right now, there really does not exist an option to do detailed parametric CAD design in VR. So what I showed, see on this slide, like this design here, there's just nothing to do that in VR right now. And maybe there are reasons for that, but I don't think that anyone's even working on it that I know of, and I'd like to know if people know differently. Integration into CAD tools is really lacking. So lots of annoying application switching. So getting into Gravity Sketch isn't too bad. And export an OBJ, and OBJ export from most CAD software is actually really robust. And I just make sure I'm under 1 million vertices or whatever, and away I go. But CAD companies seem to be sort of stuck in this trough of disillusionment mentality. So a lot of you who've been around for a while know that we sort of hit this peak of inflated expectations in like the 2016, 2017 timeframe. And then there was sort of a trough of disillusionment in the 2019 timeframe. And now we're like truly on the slope of enlightenment. And at least I've been trying to communicate that to the mechanical community that VR is really, really ready. So to engineers out there, just make your needs known to industry, and the more forward-looking institutions, groups are going to listen to it. Okay, that's my last slide, so I can take any questions. I probably went really fast.
That was an excellent presentation, and kudos on the live demo. Those are always a challenge. I do have one question. So you showed a lot of static parts. Can the system also incorporate moving parts as part of its design criteria?
No, this is Gravity Sketch. So this particular tool is really designed. A lot of folks use it in the automotive industry, in the fashion industry, and other really design-heavy industries. So it really isn't quite set up for my use case, but it does have extremely robust geometry creation tools, and it's very performant in terms of how it deals with lots of triangles.
Okay, thank you. Any other questions around the loop? Let me see if we have any in the chat bar. Oh, I guess one question I've had, your locomotion method, is the little rowing motion the only way you can get around? I guess you get your steps in every day pretty easily.
No, so there's also the banana method.
Banana method. So
Here,
bananas, and avocados.
hold on. Let me pull my my VR back up. Okay, can you see that?
Yes.
So I've got this like, teleporting banana.
Okay.
And the way this tool is really intended to be used is you're kind of supposed to unlock your you can shrink things really tiny. So now you see everything that I'm working on is tiny. And then I can just, move myself really quickly that way and move things around and then just, scale myself back up to 100% through this nice little haptic snap. So I do keep losing my space in the room, so I'm never quite sure who I'm facing.
All righty. All right. Well, any other questions around the loop? All right. If not, again, thanks for the excellent presentation and demo. Moving on to the next presenter. Oh, well, we have one question. Was Gravity Sketch originally intended to be a 3D painting program?
So it was really intended to be a 3D a modeling, like a quick modeling program, kind of like you can think of it as like a Blender replacement.
Got it. Okay. All right. Well, thank you. All right. So next up is